Hi dear students. So last day we were studying about remainder theorem and its application. Today let us go to the next theorem, the factor theorem. So actually what was remainder theorem? If you are taking a p of x, a polynomial in x, and if you are considering a letter a number a, small letter a, and if this p of x is divided by x minus a, and if you want to find the remainder, what will be the remainder? The p of a will be the remainder, means x minus a dividing by x minus a. That's why p of a will be the remainder. That's what we studied in remainder theorem. And now one more thing is added to this one so that this will become factor theorem. Just listen to this one. If this p of a, I told you how to find the remainder. By finding the value of p of a, you will get the remainder, okay? And if this remainder, that means if this p of a is equal to 0, if the remainder is 0, then we can say that x minus a is the factor of the given polynomial. That means whenever you want to find whether it is a factor or not, just check out the remainder, and if the remainder is 0, we will say yes, it is a factor, and if the remainder is not 0, we will say it is not a factor. That is the only thing which is having that is the only difference between remainder theorem and factor theorem. Factor theorem is a higher extension of remainder theorem. We can say like that also, okay? So let us get into the exercise number 2.4. Question number 1. Determine which of the following has x plus 1 as its factors. Means here we are going to take some polynomials and we are going to find whether x plus 1 is a factor or not. X plus 1 is a factor or not. Remind, x plus 1 is a factor, means x plus 1. If x plus 1 is a factor, then p of minus 1 should be 0, right? That's what right now I discussed with them. That means x plus 1 is equal to 0. X plus 1 is equal to 0 means x is equal to minus 1. That's why I say p of minus 1. We will check p of minus 1. And if p of minus 1 is 0, then we will say it is a factor. So let us check. First question. X cube plus x square plus x plus 1. That is a polynomial. So p of x is equal to x cube plus x square plus x plus 1. What we have to check? P of minus 1, right? So p of minus 1 is equal to minus 1 cube plus minus 1 square plus minus 1 plus 1. Okay, wherever you saw x, you just substitute the value with minus 1. Okay, now minus 1 cube, it is minus 1 itself, plus minus 1 square, it is 1, then minus 1, then plus 1. Here you can see minus 1 plus 1 minus 1 plus 1. That means minus and minus, two negative numbers are there and two positive numbers are there. Minus 1 minus 1, it is minus 2, plus 1, it is plus 2. Minus 2 plus 2 is 0 itself. So you got it as 0, means if the remainder is 0, the remainder you got it as 0. What does it mean? If you are getting a remainder as 0, it means that x plus 1 is a factor of x cube plus x square plus x plus 1. So like this we can understand, but just by understanding the remainder which we received, from the remainder we can say whether it is a factor or not. So like this, just check out the another questions which are given in the textbook and find the answers and make sure that your answer is correct. Here the notes is given in the below part. From the notes you will get the solutions also. Try it for yourself for one time. So next let us go to the main question number 2. Use the factor theorem to determine whether g of x is a factor of the given p of x. Here the p of x will be given and g of x will be given, and we have to determine whether g of x is the factor of the given p of x. Question number 1. P of x is given. P of x is equal to 2x cube plus x square minus 2x minus 1. That is the p of x. And what is g of x? G of x is equal to x plus 1. Now you have to check whether this g of x is a factor of the given p of x. If this g of x is a factor of p of x, how we will check? The remainder which we obtain should be 0. How to check the remainder? You have to equate the given g of x to 0 and find the x, and that value of x, that p of x you have to find. So let us find it out. Here g of x is equal to x plus 1. G of x is equal to x plus 1 means x plus 1 is equal to 0, equating it to 0. X plus 1 is equal to 0 means x is equal to minus 1. So let us check p of minus 1, and if this p of minus 1 is 0, then we will say it is a factor, and if this p of minus 1 is not 0, we will say it is not a factor. So let us go for it. P of minus 1 is equal to 2 into minus 1 cube. Why minus 1 cube? Because x cube it is. So minus 1 cube. 2 into minus 1 cube. Next time is plus x square. So we will write plus minus 1 square. Right? X square. Instead of x we are giving minus 1 square. Minus 2 into minus 1 because x is minus 1. So within brackets minus 1. The last term minus 1 like that itself. Minus 1. That's equal to 2 into minus 1 cube. What is minus 1 cube? It is minus 1 itself. So 2 into minus 1 plus minus 1 square, it is plus 1 itself. So again plus 1 minus 2 into minus 1. Minus 2 into minus 1 is minus into minus is plus. So plus 2 and the last term minus 1. So we'll get minus 2 plus 1 plus 2 minus 1. Let us add the negative numbers together. Let us add the positive. What are the negative numbers here? 1 minus 2 is there, 1 minus 1 is there. So minus 2 minus 1, it is minus 3. Then here 1 2 and 1 1 is there. Both of them are positive. 1 and 2 are positive. So 1 plus 2 is 3. So minus 3 plus 3. What is minus 3 plus 3? It is 0. That means you got the remainder as 0. What does it mean? So we can write it like this. Yes, x plus 1 is a factor of the given polynomial 2x cube plus x square minus 2x minus 1. That was our question, whether to check. So if in case when you're checking and you are finding the remainder and you got minus 1 or you got 1 or you got something else other than 0, what will you conclude? You will conclude that as the remainder is not equal to 0, the given g of x is not a factor of the polynomial p of x, like that. Okay, by seeing the remainder only we can conclude that whether it is a factor or not. Hope you understood. Main question number 3. Find the value of k if x minus 1 is a factor of p of x in each of the following. That means actually here you can see the first question, p of x is equal to x square plus x plus k. That means there is a new term k. K means actually this k is a constant number because it came towards the last. So definitely k is having a value and we have no idea what the value is and we are supposed to find the value of this k. And what is the hint given? The hint given is x minus 1 is a factor. Up to now we were checking whether it is a factor, whether it is a factor, whether it is a factor, like that we were checking. And here in this question you can see it is already mentioned that x minus 1 is a factor. What does it mean by x minus 1 is a factor? That means x minus 1 is equal to 0. That means x is equal to 1. Right? X is equal to 1. It means that p of 1 is equal to 0. That is the meaning. If x minus 1 is a factor, p of 1 should be 0. As I told you in the starting of this section, if x minus a is a factor, then p of a is equal to 0. Or just opposite, we can say like this: if p of a is equal to 0, then x minus a will be a factor of the given polynomial. So here x minus 1 is a factor, that is the given thing. So x minus 1 is equal to 0. That means x is equal to 1. That means p of 1 we have to find, and this p of 1 is 0. P of 1 is equal to 0. Why we are demanding like that it is equal to 0? Why can we say like that? Because it is given that it's a factor. We are not checking it. Up to this question we were checking whether it was a factor or not. But in this question it is specified, right? It is mentioned very clearly that it is a factor. So we can say as x minus 1 is a factor, by remainder theorem what we can say, p of 1 will be equal to 0, because the factor theorem says that if x minus a is a factor, then p of a will be equal to 0. And if p of a is equal to 0, that means x minus a will be a factor. This is what we call the factor theorem. So taking that into concern, we can say here as x minus 1 is a factor, p of 1 is equal to 0. So we will write here p of 1 is equal to 0. So now p of 1 means, what is p of 1? Wherever you are finding x, you have to substitute it with 1. So what you will write? X square plus x plus k. That was the p of x. So 1 square plus 1 plus k is equal to 0. Okay, p of 1 is equal to 0. Now what is 1 square? It is 1 itself. 1 plus 1 plus k is equal to 0. 1 plus 1 is 2. So 2 plus k is equal to 0. Therefore k is equal to, bringing 2 in the next side, it will become minus 2. You got the value of k as minus 2. Next question. Here p of x is equal to 2x square plus kx plus root 2. In the previous question k was in the last position, now it came in the centermost position. That means along with x, it came as the coefficient of x. Let us deal with it. So what is our p of x? 2x square plus kx plus root 2. Again we have to find p of 1 itself, right? P of 1 is equal to 0. Already we know that as x minus 1 is a factor, p of 1 is equal to 0. So p of 1 is equal to 0. That means, that implies what it is mean here, 2 into 1 square, because it is 2x square. So 2 into 1 square plus k into 1 plus root 2 is equal to 0. Now 2 into 1 square is 1. So 2 into 1 is 2 itself. 2 plus k into 1 is k itself. So 2 plus k plus root 2 is equal to 0. Now keeping only the k on the left hand side and taking all the other terms to the right hand side, k is equal to minus 2 minus root 2. Both of them will become minus, right? Minus 2 minus root. That's the answer. In some case, if you want to make it much more beautiful, you can do like this also, taking out the minus sign, because both of them are minus. You can write minus of, means after minus put the bracket, after minus start the bracket. So minus of 2 plus root 2, bracket closed. Like that also you can write, doesn't matter. So this is how we deal with the factor theorem. It's so easy. If we know that something is a factor, if it is given x minus a is a factor, then we will conclude that p of a is equal to 0. Or in some cases it will be given p of a is equal to 0. At the time we will say that x minus a is a factor. That is the meaning of factor theorem. Hope you understood this theorem. That's all about today's class. So we will meet in the next class with a new section. Till then, take care and goodbye.